Hello, hello, hello. So, let's see here. What's happening? So we're doing some Carl 2D programming today. What does that mean? What does that mean? Here is one of my examples. This is the most minimal. I used to have some text rendering and some shapes and some stuff. And then we have stuff like my snake game with the font rendering is a bit messed up right now, as you can see. It's a bit blurry, but we have that working using this 2D library. And this is a Raylib game I ported over, and it leaked some memory there. That's fine. I'll fix that. Stuff like the Raylib bunny mark. We have bounce around some bunnies like that. All good, and it's 2D game creation library written in Odin, similar to Raylib, but everything in Odin. I'm trying to use slightly less dependencies than Raylib also. Hello, Zidillo. And we have some font. I have put in some kind of font stash stuff. So we have like this. I can hold this to swap between two fonts and stuff. That's all cool. I have also started working on a web, not an OpenGL backend. So this is currently, all these I show you was Direct 3D 11, right? Running on the Direct 3D 11 backend. But we also have a OpenGL backend, not a WebGL. We have an OpenGL backend also, which is this one. But this one, as you see here, you saw this demo, right? Hello, the Tarnav. This is Direct 3D 11, and I keep saying WebGL. The OpenGL one looks a bit sad. There are some reasons for that. We're probably gonna do Direct 3D stuff today because there are some things we need to tackle. But I can show you the OpenGL one looks a bit better if we remove, because I don't have the texture sampler set up yet in OpenGL. So if I remove the color, because it's here, this line here sampled black because the texture wasn't bound. So if I remove that, then at least the shapes look the same as in the D3D11 variant. So this is with OpenGL, and the font is rendering just the rectangles because it doesn't have a texture, so it doesn't have the atlas for the font put in yet. But that's fine. But yeah, so what are we gonna do here today is probably, yeah, we're gonna do some Direct 3D funny stuff. So I have my library. It's, by the way, it's on, I think it's linked in the description, the link to the library on the GitHubs. But it's not ready. You can play around with it, but it's not ready for like, I can't promise that things won't change. And currently the D3D 11 is the only thing that kind of remotely even works a bit. There's no sound support yet, but you can render textures, shapes. You have the, like I showed you, and there's also gamepad support. I have my gamepad demo here. I can do all the, like that stuff, the vibration and stuff, on using X input on Windows. How to is asking, is making programming books profitable? Yeah, the Understanding the Odin programming language book I made, which is also linked in the description, it's an ebook, but it's made more money than my video game certainly did. But maybe there was a bigger demand for it in the market, so to speak. But yeah. So what I was thinking here today is that we're gonna, currently the texture stuff is hard coded, so there's only support for one texture. So this is the GLSL. So currently I have separate shaders for OpenGL and Direct 3D, but I will supply the default shader if you think about Raylib, like if you just start out, you don't use like you start out with the default shader and use that a lot, and then maybe you start making your own shaders a bit later. So I will supply all those, but then if you want custom shaders, then there's, that's one of the biggest can of worms with rendering, programming with multiple backends. Like, what do you do for shaders? But we're not going to tackle that yet. We might do some cross-compiler in front. But this is the GLSL shader that has both the vertex and the pixel shader here. So this is the vertex shader here, pixel shader. As you can see, it samples a texture here. That's can do the font example. That's this texture, the atlas for that, or the text here also uses that. And we can also load other textures. We could go open the minimal example, and maybe we can do like, do I have a load texture from file? Okay, yeah, we can do that. Right. I do have some picture somewhere in one of these samples we can steal. Maybe I have a picture in here. Pictures. We take this cat. It's always good. Like that. So let's just render a picture also. So we have because I want at least 2 textures flying at once. Draw texture takes at 10, 200 maybe. That's the position, and then the tint you don't need to put in. It didn't work. It's also I think. Oh yeah, I remember. I've done exactly this on a previous stream. The JPEG support is only for baseline, and this one is progressive. I've done exactly this. If I like do this and open it in, I don't know, I have the new Affinity, but let's open it in the old one. I bought Affinity Photo once, and now it's free. But is Carl 2D cross-platform? It will be. I'm currently making a an OpenGL backend. Okay, screw that. I'm currently making an OpenGL backend. Here's the cat. If we just resave that, does that? Yes, then it worked. So it was progressive. I just open it, hit Control S, and then it works. So now we have, this is one texture and this is another one, right? Good. So if we removed this, for example, then it would just be white, because it has now this is a rectangle with texture on it. But yeah, it will be cross-platform. I'm doing the OpenGL backend so that I can do a Linux version, but then I need to do the windowing on Linux also, and I try to use as few dependencies as possible. For the windowing on Windows, I use the Win32 API. On Linux, I guess I have to do X11 and Wayland. I don't know how that works. I have Linux on my laptop. I would maybe install it on this desktop or something. We'll figure it out. It's gonna be hell, but it'll be fine. So if we look in Carl 2D here, this is the main file, the platform independent part of it, and the rendering API independent part. Here you see I do win.init, and I say here the win is window interface win32, and that's this thing, which is just a implementation of this window interface. So this is a window interface, and it just opens windows, and it does all those events. Maybe I'll put the gamepad and key events in a separate API at some point, but Wayland supports the X11 protocol. Okay, yeah, we'll see. Yeah, it's gonna be a can of worms for me, because I like doing these things without using GL, what is it called, GLFW or whatever. Like I want to, like, it's nice to like. So the thing about this library is that I want to make it easy to get started with, like Raylib, but I want also to make it easy to ship with. Raylib has a bit of problem with like too many. When you're programming in Odin, it's a bit problematic that when you need to debug, you need to go into CLib, And then it also has some dependencies in turn that it goes to. If the library did as few things, the library did as few things as possible, like use as few dependencies as possible, then there are fewer things that can go wrong when you're trying to ship a game. Because using lots of libraries is good to get quickly started, but it will be bad for your users later when they try to ship. I mean, of course, there are some libraries that it might give you easy access to extra platforms which you want to ship on, and that's another thing. But I mean, like bugs in how easy it is to fix bugs in the library itself and stuff like that. So this is here I will have another window interface on Linux. Currently there's only Win32. For the rendering interface, it says backend here, and backend is actually from here, I think. Is it config.odin? Yeah, this one. It says like default backend on Windows is D3D11. If there are some other platform that doesn't exist yet, it's GL, and then you can using a command line argument. Like if you look in my project file, blah blah blah. Here is the minimal example how you run it, and it you define call to do back in GL or define call to back in D3D11, and that when it's compiling makes it switch what this backend thing means, if it's D3D or GL. That's how it works right now. So that's how it chooses the backend for the rendering. So there's a separate interface, and this is another interface, of course. Like if you look at this one, the render interface D3D11 is an implementation of this render backend interface. So it implements all these little things, and that's all it's like it's a 700 lines right now of D3D11 in here. Yeah, but anyways, enough talking. Enough talking. Now we're gonna do some what we came for. So we have the problem right now. I'll show you here. Is the following. We have in draw here. So this is the procedure in the D3D11 backend that draws, and it takes a shader, a texture, a scissor, like exactly what things come in here is. This will change a bit. For example, the texture is a bit weird because you can have multiple texture, right? Well, currently you can't, but that's what we're gonna change. So you have the texture here, and the textures you set on here, and you see it just says set shader resource 1 texture, and then it takes the whatever it's called, the shader resource view, SRV, as people sometimes say. So it takes that one and it sets it. And this thing, if we go and look in here, this thing is PSS shader resources. It just says start slot and how many views. So start slot is 0, and that's just because it's currently hard coded to like take the first slot, the first SRV slot, I guess it is. Or something like that, and that's 0. And then it sets the sampler as well. A sampler is the thing that decides how is it gonna fetch information from the texture. Is it gonna use some kind of filtering, blah blah blah. So we currently, this is hard coded, as you see. So we would like it to be possible for it to set like this thing and this thing. Well, at least this thing. We can start with the sampler. We can leave like that for a second. But this thing we need to make somehow configurable, and that means we need to go into the shader stuff and use shader reflection to fetch all things that can happen, all the textures that are in the shader. Because if we look back at HLSL here, here's the texture. So my load shader thingy here already does reflection for this. What are they called? The constant buffers, these guys. So And it does that sort of here somewhere. If we look, blah, 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 blah. Here it's sort of, this D3D desk comes from ref here, which is eye shader reflection. So it gets the description from here. And this uses shader reflection, which is a way to get information about the shader from the shader itself. So you can ask the shader, what constants do you have? What inputs, like vertex inputs do you have and stuff. So, and then, you know, it looks through all the constant buffers that the reflection tells us about and loops over them. And then it loops over the variables inside. This is a variable here. So this is the constant buffer. This is a variable. So it loops over them here. And it takes like, it records some data for the backend here, like where is the which buffer is it in? Well, it's in this buffer that has an index, and then it's like at which offset does start. This one starts offset 0, and then it records some rendering API independent data that, you know, if we look at the rendering backend GL, render backend GL, then there is something very similar. This one is a bit less done, so everything here is a bit more all over the place. Here I'm doing something similar. You see, I'm doing this is the GL specific part that is stored in the backend, and this is the stuff that is returned to the Carl2D stuff, like that. That is so that the library can reason about the shader in a rendering API independent way. You see, this constant desk series is returned down here. So the desk.constants, which is these guys, are returned. So the Carl2D library, when it does load shader, here it loads the shader and gets this description. Then it can loop over the constants. It can look at the inputs, which is the position and the UV and the stuff, and figure out some default formats for them and stuff. And also it has enough information for you to put in overrides if you need to. Anyways, and also in GL I support both uniform blocks and standalone uniforms. What that means is, you know, you can have like this, or you can have like I don't remember the syntax right now. You can have something like uniform blah 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 with like something like that, which is, there's supposed to be something in front of here also, but I don't remember, which is similar to this. So this is more like a constant buffer. There's a buffer you can just write into. But for some reason, people in GL often tend to, like, unless they have advanced needs, they just tend to have them loose like this. And this is for this case, and this stuff down here, blah, is for the block case. Anyways, that's the GL stuff. Not so. Let's ignore that for a second. But the problem here is that what is the problem? Is that we are not reflecting. You see, we're reflecting this stuff, and I can show you how, like, we can do like a float free offset. And we take that and we add it to the position. You see, I just added a constant that will be the same for everything in this draw column. I add it to the offset. If I run this, well, okay, I've also broken because I removed the color, right? If I run this, everything still works. Because I think maybe it has some 0 value by default. It's AVEC 3, you know, it's 3 values, but I can go to my minimal example and I can do this stuff. And this is a thing that you can't do in Rayleigh without modifying the Rayleigh source code, but I support doing this. You can do k2.set const on the OLS has died on us. Whatever. Oh, there you go. if you fetch out the default shader, because by default you don't have if you load a shader manually, of course you have then you have a shader here, and then you need a location, and then you def shader dot locations, what's it called, the constant lookup, and then it's called offset, like that, right? And then you say what the value is, and then you just use a 50 0 0. Well, we can do 220 200. You see, now everything is shifted because the constant is set all the time. But then you can just take this line, copy it to here, and set this to 0, or just an empty like that. And then it's, you see, only this green thing here has moved now. So that's, we were able to feed in a constant. Actually, I was wrong. This is possible to do in Raylib. Sorry, I was. There is another thing we can do where we can add in extra vertex inputs, but this thing, adding constants, is possible to do in Raylib. But modifying the vertex input layout is not possible without modifying the source code of Raylib. But I can do it also. Let's see. Like, I think I do that in the snake game. I have because you saw I had this one, right? The thing I do a silly thing here. When you eat the apple, then the next one shakes like that, and that I could have done that easily by shaking it in the code, but I wanted to try to do it using a vertex input thingy. So if you go to snake and you look in the shader.hls in snake, I have that wobble here. And I just did this just to show that it's possible. So I add a, per vertex, I add a thingy, an extra thing. And that comes in here. I override a shader input. And I say the third one, I should maybe have some kind of way to use the name here. But I can say that the third one should be vec2 with this value here. And then I unset it again down here. That's just like, so when it makes the vertices for that one, it feeds in an extra thing for each one. Thank you, Rayan. The Tarnav asks, do you have a stream where you cover the idea of batching when doing 2D drawing? I see you do that a bit in Call 2D. I don't know if I have a stream where I did it. I don't remember. You have to look around. But yeah, the batching is essentially just... It's inspired by Raylib. It doesn't use instancing. It just makes a big vertex list. So, like, you look in the draw procedure here, you get like a vertex buffer here that it uploads to the GPU here into the vertex buffer CPU, and then it sets the vertex buffer here, and then it down here it draws, and then all this is like shader setup and blah 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 and some constant buffer setup. But that one is created in a backend independent way. If we do like draw a rectangle, then we see that we do vertex buffer. This is checks if it will fit, or if we changed, or if we're not using the correct texture, because the batching, can only work if you're still using the same texture, and if it can fit inside the batch. And the batch is like 1 megabyte, I think, of memory or something. Thank you, Christopher. Welcome. Christopher tried my BindGen tool that I made. I made a generator for making bindings for C libraries for Odin. Let me know if you tried it. Anyone else? And if you found a bug, please put it in the GitHub issues. So I'm trying to focus on some other projects for a bit now, but I will get back to fixing bugs at some point. But you see, this draw rector is just batch vertex, and that thing just feeds into the vertex buffer CPU thingy here. Using this code is probably not very efficient, but it's okay. And then when the draw call is full, like either when you run present, then it draws the current batch, or you know, if it changes texture, like if you do like set shader, well, then it will always run draw current batch. But yeah, if you try to, there is a bunch of different places. If you set the camera, it does that. Just things that change the stuff that's needed for the current batch. And this thing is this is a render backend draw. So this feeds in the vertex buffer CPU here, and you see just a slice of from the start to up how much memory of it we used, and then the backend will upload that to the GPU. Yeah, I'm using I'm using both HLSL and GLSL. So the shader.HLSL is this, but then there's for the OpenGL version, I have an OpenGL shader right now. There will be I would ship, you know, with a identical default shader for it. Like, you know, for the standard 2D drawing, I will at least have one for each, because they're very easy to write, the default ones. But then if you need to do custom things, either you will need to write them separately for different platforms, or you need to use a cross compiler. And I will try to make some kind of cross compiler thingy that sits in, like, instead of building it into the library, it will sit in front, so the library doesn't become like this weird thing that is calling into this very complicated bunch of libraries. So it's sort of, I try to move that out of the library. I think that's a good idea, because then that makes it easier again. Like that makes it possible for people still to get going fairly quickly, but it makes it easier to ship, because it's not like you're not forced to use this specific thing. All right. So let's go back. Oh, so much. I haven't started programming yet. Just talking. Socal Shade C is great. Yeah, that one is pretty cool. Socal Shader Compiler. That one essentially does like a before, like it. Yeah, that's a pretty interesting version of a shader compiler. It sort of does it before the program compiles. It compiles the shaders and stores them as bytes, the compiled shader, for whichever backend you're using. It's pretty cool. We'll see what I do, but I think I can get away for now with not deciding, just implementing the default shader for each backend. So what we're gonna do now is that we need to make it so that we can do the reflection. There's several things here. We need to do the reflection for the vertex shader and the pixel shader separately, because currently I only do it for the vertex shader, because I only needed to look at constants in the vertex shader and stuff. But you know, I will need to look for the samplers, and they are bound to the pixel shader. They're not used by the vertex shader, so it doesn't even bind them. It doesn't use them. Yeah. So we need to do some refactoring here, essentially, as they say in the business. I think what I will do is, let's see here, create vertex shader here. Here we create the vertex shader. Here we do the reflection, and here we feed in the blob of stuff. Could I potentially just take all this stuff and throw it into a function? At least maybe not everything, but maybe we can throw like this input parameters. These don't really exist for the pixel shader as far as I know, because they're like, what's this, like this stuff, right? Maybe they do exist, because you get the input to the pixel shader, this stuff, but I don't know if it's something you really care about that much, because the pixel shader, the vertex shader writes it here, and the pixel just uses it. I'm gonna ignore that for now. The important stuff is the constant buffers here. So we start with moving that out to a little function or something. So we will take that and we will open another. I try to use, I've been using Visual Studio a bit at a contracting job I have, and you're doing this thing where you open the same file. It's very funny. You know, this thing, I have this file here, and I open this one, and I open another one with the same window. It's like not that easy in Visual Studio, because it will just, if you try to open a file, it will just pop to this one. So you need to go into a window and like new window, and then you can get a clone of for this, like blah. Yeah, it's not fun to do in VS. It's just I had to use VS for some stuff at my contracting job I have. So we have D3D constants here, like that. So maybe if we toss these out, so I want to do this for the pixel shader and the vertex shader, and somehow make sense of it all. Reflect shader constants. Blah. Put that there. Put that there. There you go. What do we need? We need shader. I call it D3D shed because there is a, you know, the shader is two parts. It's the, it's this part, which is the rendering API independent part that holds sort of like, oh, what stuff is that you want to throw into the backend later, and how can we reason about inputs in a way. But yeah, so I have that. But the D3D11 shader is like the, all this stuff that must be inside the D3D11 backend. It can't leak outside here. All right. This one needs to be a little pointer. Constant buffer. This is wrong. This is already wrong. Because I can't just have this be a list like that, because I need to add constant buffer both for the vertex shader and the pixel shader. So we will go up here. Where am I? Here. So I think constant buffers will instead be there's some bugs here. This thing needs to do like this. Make desk allocator. That's the allocator for allocating the description that will be returned to the front end. We could say. And this stuff, D3D constant, just needs to use s.allocator. I could set one of those two on the context here, but whatever. D3D constants, make shader constant, s.allocator. And then we need constant buffers to be another dynamic list of D3D shader constant buffer. And this one uses s.allocators. And this one is, we can just call D3D constant buffers. So the constants is sort of the variables of each and every constant buffer. So even if you have like if you have multiple of these, the names in here sort of leak out. So you can't have MVP in one constant buffer and MVP in another one, because you see, I just use it here without saying constants.mvp. So the name is actually global, even though it looks like it's inside a thing. So that's what goes into constants here, and the constant buffer is each of these that we will fill with memory. Right. So we can do reflect shader constants that we just made, and we say D3D should, And then we need to feed in the stuff that we're gonna fill out. So let's see here. D3D desk is the shader desk. I don't know why it's called. Can we just call it? Do we have a? It's a bit. Oh, this whole land of. Hello, Danshi. Oh, long name. Sorry. Hello, Pakistan. Hello, my Pakistani. Welcome. You know, it's problematic when you do these things because I have desks that are both like I'm returning a desk over here, shader desk, but then I have some desks that are from Direct3D 11. Then I have some stuff from Direct3D 11 that also says desk. So that's why there's the D3D, just to make me not confused. So we have D3D desk, but it's yeah, it's fine because we're talking about the shader and they were inside load shader, right? So D3D desk, shader desk. Well, that one doesn't really need to be passed by pointer. And the reason we're doing these things where we return this, maybe I should make this this thing not so long. Here's a riddle for you all. What's the best way to write when you do multi-line procedure, things like this? If you have the brace over here, what's the best way to put? Maybe it should be like this, because it's a bit, always gets a bit like this here is now on the same indentation as that. I could put it back, but then it looks a bit weird. I could like space it up to here, but then it's just like that. I don't use Odin format, I'm afraid. Because it has too many interesting opinions. But anyways. Yeah, I'm not gonna move the brace. That's like I'm not gonna start putting on new lines. I'm just like this case when you have like this. It's just maybe it should just be like that. Maybe that's the best one. Like that. Yeah, it's not about how many params you have on one line. It's just that when this ends up on this column here, it looks like it's part of, like when you read from here, it looks like this is a part of the function, right? Anyways, whatever. It's not that important. It's just a thing that I sometimes like. But it's quite fine because this part won't change. I won't rename it that often, so this is not gonna move this part. So yeah, I think this is the best way. Yeah, for structs I put them on separate lines, but it just doesn't. I don't know. Better figures to buy an ultra wide monitor. Yeah, not very good for streams, is it though? Ultra wide stream. Everyone is watching also needs to buy an ultra wide monitor. Actually, I'm hired by Big Ultra Wide to make everyone buy ultra wide monitor. So we have moved this to a little procedure down here. So we're going over the constant buffers. Ref here is the reflection interface. Maybe we'll toss that in too. Okay, maybe I'll do what you say. Maybe I'll try. I don't know. Maybe I'll do what you say. Maybe I'll try this. Just a ref is an d3d11.i. Yeah, maybe this is the good rule here, that if you go past the ruler here, which is at I put it at 100 usually, then you put each in one line. I shader reflection. Is that a pointer? Yeah, so I will do this. So there you go. Oh, of course, a pointer. I can see that from here. So we have that CB info, CB task, blah blah blah. Of course, this won't work. And this is nonsense now. Oh, yeah, then we need the out parameter sort of. We need to add to constant tasks and d4d constants. Constant task is a dynamic, is a pointer to a dynamic array of shader constant task, and then d4d constants is a pointer to a dynamic array of d4d shader constant. No need for that little ampersand anymore. Right. Go back. For now I can do this maybe. Constant tasks is there, d4d constant there, constant buffers. What happened to you? You poor thing. Constant. Oh, it's here. It was added by index before. Append d3d constant buffers. What is a d3d11 constant buffer? It has a size and a buffer. Oh yeah, it's here. So we just do this. So we say it's buff here instead. So what I'm trying to do is generalize this code so I can use it both, because unless if that was unclear, like you create the shaded reflection here for the vertex shader here, right? But I will need to do the same thing for the pixel shader. I will need to do it for some of the things like constants, and then we'll also look at, we'll start with the constants now, and then we need to do it for, what's it called? We also need to do it for as textures and samplers, but we fix the code we have first for that. It's already there. Danish code says, what's your take on vibe coding folding? I don't know. I've never used any of that. I think if you want to be a programmer, you need to write. You need to know what your code is doing, so you need to write your own code. The moment you start relying on too much stuff like that, you will slowly become bad at doing stuff. Even though it feels like you're saving time at the start, you will. It's sort of like using, you're a baker, and instead of, doing like everything from scratch, the little, you do all the little fillings for your little pastries from scratch. You start buying like shake and bake, and like nice. It does the same thing. It feels a bit like, you will lose, even if you do that just once. If you continue doing it, you will lose your craft. Don't shake and bake unless you're not a baker. Then shake and bake always. What is Constant desks. Desk allocator. This desk allocator. There's a bunch of things going on here. What is this? This is a runtime.allocator. So much stuff here. Oh, because it needs to clone a string here. That's why it needs the allocator. Right. Constant buffers. Right, that's the one. This one, right. We also need in here. D3D constant buffers. Like, you know, when doing this stuff, I have to meticulously think all the time about, like, in order for this library to be any good at all, you know, I think a lot about, like, what is the API gonna be like? How easy is it gonna be? Is it gonna be like friendly to use? Like when you open it for the first time, is it easy to find the things? Those things, can you easily, like, you know, get things to work nicely? How does the front end relate to the rendering backends, and how do we split it up? How do we use minimal amount of dependencies, and how will we maybe leverage what we do in GL so we can clone that to make a WebGL backend, and, you know, all that stuff. I'm trying to think of all the stuff. The moment I would add like uncertainty where I don't know anymore what I'm doing, or like what would be like this kind of, you know, this kind of what people call vibe coding. If you did any of that, you know, I would just completely lose track of what I was doing. It would no longer be a good, like, I would not be able to create a good library for other people to use, because it needs to have this cohesive idea that comes from like 5 directions at the same time, that you can't sort of like just patch up. Don't shake and bake. Yeah. Chaser says, I do like the doc.odin is helpful. Yeah, so this is my, in case you're wondering what the hell is this, this just looks a bit off, because in Odin, like, you have this, you put that to have if you put that, you don't need a body, but these obviously don't do that. And this thing, I have a program called API Doc Builder, which takes the carl2d.odin and spits out carl2d doc.odin, and it's essentially just takes the signature of the procedures plus the comments and puts them in a file, and this gives you, you know, the same overview that a header gives you without having to have a header. So I generate, you know, I hate having headers, but they're good for documentation and giving a quick overview, and also for seeing if something weird happens in like a pull request, because then you can see like, oh, what happened here. So this thing will be like, yeah, so when you look for when you want to see how something works, like what's available, then you look in here, and this is generated just from this file, but it's sort of without the bodies of the procedures. And the way I do it is I actually scan for it also, here's a raylib. I put the raylib colors in. I have my own colors here, but I put the RL colors in just so you can easily port raylib programs. Anyways, and then, you know, it's if we look inside here comes all the procedure signatures, and then comes the struct definitions and constants and stuff, and then I do show the internal state of the library in case someone wants to poke at that. I'm not trying to hide it from anyone, but you probably shouldn't poke too much in here, but you can. And then there's the keyboard keys and gamepad buttons, and then it ends. And the way this works is actually that there is an API, and it just uses the Odin in core Odin. I can show you the API builder. It uses the Odin parser here, it parses it, and it makes an abstract syntax tree using it, and then I go through that, and this is this file, not this file. Where's the doc file? This file, you know, is generated by just running this program. That's all. And what it does, it just looks for the Carl2D file, because it takes the whole package, but it just looks for that one, and then it goes through them and it writes any proc literal, and then it just takes the name and the type without the body, and then if it wasn't a proc, then it will take the whole thing, because then it's probably a struct or an enum or something. So that's what this does. And then if it runs into this API end constant, then it stops. But before, but unless it runs here, it will just keep printing to this file, and then it closes the file, and it puts a tiny bit at the top here. And then you have your header, like you get all the benefits of a header without having to have a language of headers. With a 75 line program that just does some. This I just run, and I'm probably gonna put this. Somehow I'm gonna put this into the GitHub action so that it can generate a doc file. So if I have a pull request where the doc file differs, like it generates a new doc file and it's not the same doc file that's in the repository, then it will error, so that you must update it. So you see if the doc file changes, then you must have also committed updated one, so it's identical in the GitHub action, because then you would be forced to look at a doc file when you're doing a pull request and see, did I actually change some API? Because that's a problem with Odin, that it's too the API surface is too much, because everything is mixed with the procedures of the library. Like everything, you know, like good luck looking inside here and trying to find, like, oh, did I accidentally add a parameter here? But if you can of course do that by looking at the good luck was a bit harsh, but it's easier to miss. But if there is a change in the API file, if you see a change in API file in a pull request and you're forced to have the same one, you're forced to have it up to date, because the CI will check it for you. Then you can look in just that one and see, like, did I change my API? Because changing API is not good, because you break people's code. But it's easy to accidentally, like you're doing something in the backend and you accidentally did something to the API. I think this Odin core would be cool, but also nightmare to do. Yeah, well, the thing is, you know, you have the doc. People might be like, oh, but you have the document. No, you can go here. You can go to odinlang.org and go to documentation, of course. And that's what some people be like, oh, Carl, why do you care so much about this? Where is the documentation? Oh, it's the packages. The documentation is not under docs. You know, you have all this, of course. You have this for the core collection, which is sort of gives a similar overview. You can look at the crypto and see all the procedures and stuff. But I don't like opening web browsers. I like being in my code. Like, you know, I like when you're using Raylib. Okay, I don't have Raylib in this. But, you know, when using Raylib, the nice thing about C libraries in Odin is that you get bindings, and the bindings have a good overview. But C bindings in Odin have a much better overview than Odin libraries, because you have the, like, you know, if you just all C libraries have a good overview. You can make good overview from Odin library, but you need to do something extra, like either have a documentation that's generated, you need to look up online, but I don't like that. I like this stuff, you know. I like this stuff. Raylib. Where is it? There. You know, having this, see all the procedures without all the noise of their bodies. This is much better overview than any other Odin lib I've seen, because it doesn't have the bodies there. And this is similar to a header file, of course. The bindings is similar to a header file, in a sense. Mikael says I'm to gets too easily distracted by opening web browsers, opening documentation, so they saved it to an offline. Yeah, the Odin. Yeah. I don't like opening web docs. There was something else someone asks. There was so many asked questions here. Wasn't there? Is and was in. Oh, now I get what you mean. The what? Carl 2D is was. No. Did I have that? Is. Oh, you mean? Do you mean went? These maybe? Key is. I have these, of course. Key went down, key went up, key is held. I've spent a lot of time thinking about these things. How do you, like, in Raylib, it's I'm getting so distracted here. I'm not getting anything done, but it's fine. You know, in Raylib, it's like is key is key pressed and is key pressed and is key down. Which one is that it's held and which one is that it's went down? It's very easy to, like, you of course you learn it by using the library a few times, but the first time you use it, but here I thought a bit about, like, what is it that these procedures actually mean, right? So this one, detect if a key has been pressed once. What it means is that the key went down the most recent, between the previous frame and this frame, the key went down. And what this one means, is key released, means did the key between this frame, the previous frame and this frame go, did it go up? And down is it held? So I will spend some time actually thinking back and forth, like, well, what is the best way to express that? And I came to the conclusion that key went down, key went up. It's sort of past tense, and then key is held. And I think to me, it's like completely unambiguous what that means. So I think that when I realized, oh, the word went, very good. And it also, it reads nicely. I can scan this easily. I think I have my snake.odin game. Hola. You see here, key is held, key went down. Like it somehow, it's also important that there's both something at the end, like to look, because you often tend to see things more at the end, the beginning and the end of something, than in the middle. So you can see held or down or up, and then you also can scan the middle. If there's a big word or a small, like, it's just something about it that makes it easy to scan. These are the kind of things like API design things that I think about, that first impression, like, it needs to be And then it went on to gamepads as well. Gamepad button went up, gamepad button went down, is held. Mouse button went up, went down, went up, is held. Yeah. I'm using key went up right now. Yeah, yes, Chaser is one of my few users. Chaser has been trying out my Curl 2D stuff. You're all free to. You can all try it. The GitHub link is in the description, but be aware, things will change. It's not production ready, but you can try it. Chaser asking how is went up different went down. Went up is when you release it. So went down is that between the previous room and this one, the key went down. And if you keep holding it, nothing's gonna happen. And when you release it 5 seconds later, then key went up. So it just it went down or went up. It went down by itself. Key went downtown. Yeah, and then it's the is held is, of course, if it's currently held, if you have pressed it down but you have not yet released it. Pikmin asked, did you archive the whole process of this? Or was it chatted between time and space? I like that. That's a very good way to ask, did you record everything from the creation of this? No, I didn't. It's shattered in time and space. Yeah, I don't know about trying to minimize the enums or something, but anyways, hello Robbins. Anyways, let's try to get something done here before. And you see the clock here? It's not early anymore. So I need to get something done. I need to at least move out one procedure. Streams are not very efficient, but it's fun, right? Shader reflect constant. Programming stream moment. I am currently having a programming stream moment. Right, that. Okay, I think that's all we need to throw in there. I got very distracted there for a while. Constant desks. No, constant desks. And then d3d constants. And then d3d oh, this got long. You know what we're doing. It's the latest thing. D3 constant buffers, and then the desk allocator. That's a lot of shiz. D3 shader. Do we even need that? I don't think we need that. That was just because I need a desk, but I don't need this. Go away. Okay, and then after that, I will do d3d shade.constant buffers equals d3d constant buffers like that. These two should come out as the same length. Let's try to compile. Let's see what happens. I think that worked. Yeah. Cannot find shader constant. What are you? Oh, because I have in minimal, I'm still doing this crap. It's complaining about, it's trying to look up offset. Remove that. There you go. So now we've done that. Ref D3D desk. There are lots of problems here. D3D desk. This is D3D shader. That's okay. That one we can move up a bit to here. But then comes the vertex shader stuff. So we have the vertex shader. Here we create, this is the vertex shader code comes in here. And then we have the shaded reflection. That is comes here. And then we make that. So this shade reflection is the VS reflection. Because we need one for VS and one for pixel shader. And then this is the VS desk, not the D3D desk. So we use the VS ref to get the VS desk. Compile, fix the compile errors. VS desk. D3D desk. VS desk. And then with VS ref. VS ref. Compiles. Good. VS ref, VS step. Okay, that's all. That looks nice and tidy. And then we need, here's the input layout. This stuff. Why is this happening here? Why is it? Why can't I do? Well, it doesn't really matter. And then, you know, so we have that, and then we do this vertex shader, blah blah blah. I like that this one returns, but the other one doesn't. Interesting. Okay, PS blob. Pixel shader here, and then it just creates it. So you see, it doesn't do, the pixel shader doesn't do any reflection at all yet. So we need to do some of that stuff. Take this one, go here. Whatever. Oh, I already did that. So this is the the PS ref and the PS ref, and here you need to do that, not the VS blob, the PS blob. The blob is just this is just the compile. I'm using the D3D compiler right now. I could switch to DXC, but I haven't had the reason to, and it's just easier to use D3D compiler because, yeah, it's a bit easier to get going with, but it doesn't support as late pixel, doesn't support as late shader versions. They essentially you can use D3D compiler for a bit older HLSL, and then you can use DXC, the DirectX shader compiler, for a bit newer ones. The cool thing about DXC is that it can also compile to SPIR-V, which you can then use with Vulkan, for example. Not that I'm gonna use Vulkan probably. I might just make a GL backend instead for Linux or something. But well, I already made a GL backend, so but I'll do that. Vulkan is like, it's so hard that D3D11 is the easiest graphics API, by the way. If you want to learn graphics programming, start with D3D11. It's the easiest time because you actually understand what things do. Like creating an input layout like this. You have an input layout desk, and the input elements that describes the inputs to the shader, like the position, the color of each vertex and stuff. Easy to understand. You have an input layout. You bind when you draw. You set the input layout, and then you're done. And it goes on. I have the GL backend, backend GL. It's not as simple. It's not as obvious. Then you have something called a vertex array object, and for the vertex array object, I bind it, and then I go over and enable vertex attribute arrays and set weird pointers with lots of things, and there's never really there's not a struct you fill out where you see what the fields do, which is this weird stuff that this is like, I think many people learn OpenGL and they're like, oh, I'm having quite a good time. Like they get the little rectangle on the screen, and then they need to learn about the vertex array object. I think that's when some people are lost, because it just becomes like weird and abstract. And and then with vertex array, when you want to set it, it's similar. Then you do I see? I never set it because this backend is stupid. It's set once when it creates it, but yeah, this backend is a bit work in progress. But anyways, yeah, graphics is taught mainly in OpenGL. Yeah, you can look up I think you have isn't there a D3D11 tutorial somewhere? But I would say it's easier to learn, and I have had quite an easy time making GL backend by staring at D3D11 code and then just thinking what's sort of the equivalent in GL, and then doing that. That's much easier to me than having nothing and like what vertex attribute blah 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 function in GL do I need to call to make something happen. It's don't start with D3D12 because it's sort of like Vulkan it gives you a lot of control, but you lose your mind. But yeah, Vulkan is the ultimate lose your mind thing, but yeah, D3D12 is a bit nicer than Vulkan, but it's so what I'm thinking is if I ever make a Vulkan backend, it will be the last. That will be the last API I make. Sounds like an ultimatum. No, but I mean it would be like after I've done D3D, GL, WebGL, and Metal. Maybe when I have those, then maybe I have enough courage to make a Vulkan backend, because then I also know because you need to set it up. You need to set everything up. There's so many extra things to set up, and setting those up in the correct way is much easier to do if you have these if you use high level APIs to sort of try to mimic what they do, instead of just being swimming in the water and trying to find your way with Vulkan. Maybe if you have a Mac, try using Metal. Metal, people say is nice, and you can use Metal natively in Odin. So maybe you should try that. And then you can use your own little iPhone, and then you can maybe make a GL backend and use some other things. Yeah, I'm almost like that. Before Vulkan, I will buy a Mac and use Metal. I probably we'll see if I even make a Metal backend. Maybe I've had some people in the community who was like, yeah, I can try making one. But it's good it's the last one that's made, so that I have made all the constraints based on D3D, GL, and WebGL already. So it's all there. So it's the more backends you make, the less you might have accidentally designed the backend interface around an API. So it's easier to maybe make it for Metal then. So we have PS Desk there. Let's take this thing Let me say PS desk, v PS ref, blah blah blah, desk allocator. Okay. This still works fine. Now it runs this for the oh look, it gave me a little error report here. Can do K2 Dutch destroy texture text. Wow. And it's gone. The device will be there, but that's a bit tricky to fix. But it's nice if you have the DirectX SDK installed. Then I print live. I essentially give you a GPUs. Like you can easily make a tracking allocator node and track CPU side memory leaks. And then you can, if you have the D3D, the Windows SDK, maybe it is some SDK it is. If you have that installed, got a attack panic to guitar. If you have that installed, then you get these. Then you can get this nice extra debug info down here. So if you remove this, let's close it. You get this. There's these two resources. Then you know. Have you thought about WebGPU? I have thought about it. But yeah, I don't know. It doesn't seem mature. I'd rather do WebGL first. Maybe I'll do WebGPU later. Then the cool thing about WebGPU is you can potentially use this as a desktop platform too. I don't know how that works. I just know that you can do it somehow. But yeah, it's not very mature API. Okay, so this is running now. It doesn't really do anything, but what I was thinking is what we should do here is try to do something like this. We go into the draw proc, and there's a little funny thing going on here. This doesn't make any sense because this is here is the constant buffer for the vertex shader and the pixel shader, and it just sets all of them on both. Well, both WebGPU and WebGL start with web, so you just have to pick a web to have. WebGPU, the reason I also want to make WebGPU before WebGL is because if you want to make a WebGL backend, then you must first invent the universe. No, that was not what I was going to say. If you want to make a WebGL backend, then you just can take your OpenGL backend, make a copy of it, and then figure. That's at least what I'm guessing. It's quite similar, but not completely. But you can fill in the differences there. But maybe I will regret that. Yeah, I could make a SDL3 GPU API backend. The important, some people were like, why are you using all these APIs? Why don't you just use SDL3 GPU? I'm like, well, so that you can easily ship on many platforms. Because you might have weird bug. Like if you have a bug in SDL, then it's like one extra layer to get through. And this is real problems, that people have on trying to ship. But the nice thing is that I make backend, several backends, so you can. The library is like future proof because you can always add a new backend for a weird platform that doesn't, and stuff. But you could also add a SDL backend. You can add a backend that just calls into SDL GPU if you want to. And maybe lots of people will use that. But yeah. And then that one can use the SDL shading language, whatever it's called. So the weird thing here is that we send in the same constant buffers to both here. Maybe we just need to do this. We do like VS constant buffers. Let's make a little dynamic array here. And we use the frame allocator. Instead of temp allocator, I use something called a frame allocator, which is it's a temp allocator, but that is cleared after each frame is done. so that the library has its own temp allocator. That temp allocators need a lifetime for how long the things should live. So what I do is I have a frame allocator that when present is done and when everything is done here, this is the end of the frame, then everything on it dies. And I write the code so that I would never need anything here after this point. Like you draw the last batch, you present it, free it all. At least that's, I hope that will work. So V is constant buffers and then pixel shader constant buffers. Blah, blah, blah. Yeah, there's lots of things here that's not gonna work. Like, I need to redesign so many things here to make this work properly. Because now you have constant, like I don't have it right now, but I will need to make it so that constants, you have a bunch of constants for the vertex shader and for the pixel shader, and maybe they can be shared if they're used in both. The constant essentially needs to know which GPU constant it, like this doesn't work, and I can just loop over these. You know, I must essentially have something like this. GPU constant IDX or something. So that it, because that information can be returned by the load shader stuffs. So if you pretend that we have that, well, okay, we can put that in later. We can, let me comment that out and we just write CIDX like that. But we just have this. Well, we need to know also if something is for the vertex shader or the pixel shader or shared. I think it can be shared. We'll see if that's a thing. I'm not sure if we have some kind of way to identify if they're shared. I guess these are the kind of things that make rendering backends more or less efficient. Like, oh, like you could just create, like you could look through the bound resources on the pixel shader and the vertex shader and then just create constant buffers. But if they both use the same one, then you could get away with one buffer and both use it. But you could also accidentally create both. And also I'm thinking about the actual GPU side memory that you map, that you use. Maybe, I don't know if that one needs to be, like maybe it can be bigger and you just use the beginning of it so that you can like have a pool of different buffers that you recycle, so that you can like, oh, I need a buffer of maximum size of 128. Maybe you have something of size 90. And then you just like, okay, use this one. And then you can use it lazily, create more of those. Maybe. I don't know. I'm figuring out this. I'm not really a graphics programmer in the sense that I do like PBR kind of cool 3D stuff. I just try to figure out like the simple thing to do, like my simple 2D use case, and do that. Like I have very tight constraints, which is more fun. Right, so we need to save some extra information here. We need to know if we're reflecting a pixel shader or a... Can we know that somehow from the... I can send in a enum also, or like a bool or whatever. But I would just like... What are these flags? Flag. Can I know if something is a pixel shader? Shader variables, blah 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 blah. Whatever. D for D11 is very easy to learn, and now it's fine, really. it doesn't matter. I just throw something in there. Shade D3, D11. Well, okay, I actually need like... Okay, for now we'll do the thing where we say shaded type. D3, D11 shaded type is a enum. We have vertex and pixel. Fine, whatever. Like that, and then we burn this into each of these D3D constants, I think. Or should it be maybe this should not be even in the, maybe this should be a non-API specific, I don't know. I haven't really figured that out yet. Shader type. So we have that there now. Since we have that, we can know which one of these to choose. That's what I'm getting at. So we do if cb dot, oh, this is the constant buffers. Wait, this is the constant. What am I doing? Well, that's fine. I'll put it there. Yeah. If type equals no. If cb.type equals pixel, well, that was helpful. La 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 la. La la la. So now, well, remove this crap. This line, but with as a dynamic array, append to vs constant buffers the cb.gpu data. If it's a pixel one, then we append to ps constant buffers. I think this is how you're supposed to do it, because then you can just make a bunch of constant buffers, right? This should be fine. Maps cb index. So this is just I create the map here. This is the map that makes it possible to copy things into the GPU. I create it up here, but I don't want to create it and throw it away, because there might be several constants that go into the same buffer, because a constant can be like a variable of, like if you have several lines here, float to blah 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 and float blah blah blah, then these are all constants and this is the buffer. But the order they come here from the CPU side might be a bit funny. So I just map it up once when I hit one of them, and then I close all the maps down here. That's the idea, at least. So now I can remove that. Okay, maybe I'm gonna have a problem now. vs set constant buffers. This thing take start slot. Start slot. I'm guessing it is that you might have several slots. The index into the device zero based array of constant buffering. So I guess this is the slot. Is it? Let's see if I change that to 1 and I put 0 there if everything explodes. That's a good test, I guess. What? So here we do length of VS, and then we do the raw data of that one. And we do the length of PM, and we have that one. Yeah, here I need to do like dot vertex. And down here I need to do dot pixel. And then, yeah, this type is in the wrong spot. It should be here. Type equals type. Yeah, that still compiles. But that's not so weird because we're only using... Let's try to mess with our shader a bit. See what we get. Let's have 2 constant block, my stuff. And this one goes into B1, and this one has like a float alpha. I don't know. And we take that alpha and we do this times float 4 111 alpha. This is the way I sort of test these things. You know, I need to do lots of experiments because this is the vertex shader, this is the pixel shader, and even though these are in the same file, they're compiled separately and they bind different data. I realized that there's actually a problem right now where I'm looping over all the constant buffer, not the bound ones. We will fix that later. Now this exploded because alpha is 0, so everything got transparent. That's fine. No, minimal it's called. Simple. Def equal def shader. Yeah, another thing I'm thinking about, you know, even though in Odin you can choose the pref, you know, with Raylib people tend to choose like, you know, import RL vendor Raylib. When even though you can choose this, it tends to become a de facto standard one you choose, right? People, they tend to be like people, like most people use Raylib and Odin use RL, and I'm like, okay, maybe most people use mylib will put K2 because that feels kind of good. But one thing, this is a kind of weird thing I worry about. I'm worrying about how most people use QWERTY layout, and I worry about, you know, how nice it feels to type. I'm like K2, and then you need to put a period K2, and then that's why I'm like, no, maybe I used it called carlib before. Maybe that's nicer to type. You know, kind of like most people will use this one, this K2 prefix, and so sometimes like I'm almost like, you know, the name isn't that important. To me, it's almost more important to choose a name that is not annoying to write many times. Like the abbreviation name is almost more important to me than the real name, because the real name can just be anything. I like writing KL dot. He's writing with one hand. K2 I have to K2 dot. Yeah. It can also be like, yeah, I don't know. Anyways, not that important. It's just something, it is this kind of funny things I think about sometimes. Now I want to make the cat transparent. K2.set shader constant def shader def shader dot constant lookup what's it called, alpha, and then we write f32. I used casting this here, so make sure that it gets in as the correct type. 0.5. We know everything will get transparent. Now, okay, cannot find shader constant. Okay, if I put it in here, then it works right. Yeah. Well, it doesn't really work because everything disappeared. But we'll figure that out. Let's try to straighten these things out. Okay, that's not a good thing. Yeah, because I use any here to... I use any here, which is a bit magical in Odin, but it sort of passes implicitly by pointer and sends in the type info. And I use that to get a value of any type and then just make sure the size is correct, and then I send it into the shader. But it's... yeah. Okay, alpha here does not currently work. So something is wrong with how we toss these. Let's get that to work first. That's a good first thing here, right? PSVS. Okay, let me log.info vs constant buffers and this oldest thing. Why does it? I don't want it to be. I can print the whole dynamic array. It's fine. Okay, so one has stuff in it and the other one doesn't. But clearly, I use things from both. So something is broken here. I know what's broken. I know exactly what is broken. Because it's not done. Low texture, low shader. Shader. This thing here can't happen here. And that one I can remove. It's not gonna matter at some point. Question is, do I even... I think I can move this. Yes. We take this guy down to here. Just do a little thing like that. Like that. Oh, why did I put dot there? That's not how you write it. And then the desk.constants. Wait, no, right, the desk I fill out sort of. The desk is actually... yeah, this. Someone is right here. It's very hard to see like this. What is this? Why have I written it like this? Put them on a line. Like this. This is much better. Nope. And then I guess the arrow goes there, and these come one at a line again. Oh, maybe that's not valid. Well, it's at least it's easy to read. It's a list of things with parentheses, and then there's an arrow to a list of things with parentheses around. I think that's fine. I think this is how you should do if you do multiple. If you do more than one, if you do one line, it's fine. But the moment you hit is too long, then you split it like this. Right. Right. Wait, did I? Oh yeah, it's all in here now. Maybe it works now. No? Okay, at least it's setting a buffer on both, it seems like. Let's open render doc and see what happens. What is it doing? This is a good program. But maybe not for it specifically this thing, but I can look at you see, I see the geometry here. These are those two, and then these come separately, and then lastly that one comes. Why? Oh yeah, these use the shapes drawing texture, these use the font atlas, and these use a separate. Here I change a constant, right? I changed the alpha, so this one comes separately. That's why you get 3 draw calls here. Right, and then we set, here you see VS set constant buffer, we feed it a buffer here, like that. I think I can look at the state of that somehow here. Right, and then we go to the pixel shader and we have a buffer here and it's all zeroed out. So the pixel shader is not getting the correct stuff. That's not so weird. I realize now. I have a problem here. Well, the problem is just that there is 2 constants with the same name used by, well, there's 1 constant used by both, so I don't think it will be able to look up it for both. Let's see. Let's see. Where is it? Load shader. So we have reflect shader constants here, and it writes it in here. It clones the name here, shader constant desk name size. Right, and then if you go to call2d to load shader, this is the independent part. Then you know it will load the shader. Yeah, now I'm just like allergic to these, like going over 100 lines. I'm like, just do that with a comma like that, like structs. Load shader, blah blah blah. And then handle constant size. Here we go over all the constants, right? We put in this. And then it's lookup here. This ain't gonna work. Because you see we're like taking the name. But really a constant buffer should only appear once. Even if, well, not a constant buffer, but what is the constant buffer? No, the constant itself, the lookup for it, which is this stuff, should only appear once if it is if it used, well, no, wait, alpha is only used in one of these. That's not the problem here. Alpha is only used here. Right. That's not the problem. That's not the problem. And I do see it set the constant buffer for both. Wait. But it creates 2 separate ones. Yes, here's the problem. It has created 2 of these, you can think, and then it has... So there should only be 1 of these, but then it can be bound to 2 different shaders. The GPU data should be the same. Yeah, this is a bit it's a bit finicky. I think I might have to turn things a bit inside out to get this correct at some point, but yeah. There are a few ways I can just hack around this to get something on the screen, of course, but I know what's wrong. Is that there are 2 alpha will just point to the first one. What happens now if I wait? Can I try something here? If I use 2 separate buffers, stuff B1 alpha. Okay, that doesn't work. That might be. Let me try hacking in a thing here just to check my understanding. Set P. Blah, blah, blah. Does this mean that this might need a 1 here? No, that was not it. And I guess I can't use the same one there because... Or does it work like that? Like, is it shared between the 2? I don't know. That didn't really work, did it? Anyways. I need to double check that. Is it actually running this? I just make a compiler. Yeah, so a compiler there. Yeah, so that's running. Bah. Essentially, what we maybe want to have here is like this. And then I'm not sure about this number. Oh well. Load shader. Where to start with this mess? Okay, I probably need to do this. I probably need to go over both shaders, vertex shader and pixel shader, right? And look, I can look up this name here, and I see if the name appears in both, then it's in both. Otherwise, it's just in one or the other. And then I know that. Then I know. And then I only create it once. Doesn't matter. It's not even created in here, maybe. Maybe it is created once outside. With the type correctly set, and then it can also be, it can be a vertex, pixel, or both. Okay. And then we just have a mapping that can sort of point us to it, and we run across the both the shaders again, and we look at the variables in them, and we set those up, and they will point to the buffer that was created, and that buffer might be whichever. There's this thing with the buffer also that I'm thinking about, that, you know, now I create, like, for each shader I go and tell the GPU, hey, create buffer, here's the information with a size. Couldn't I, like, just have a pool of these? I'm like, okay, this shader needs at least these many buffers of this size, and then I make sure that those many exist, and it just puts them aside, and then when it's time to render, it just fetches lazily. It fetches those buffers, even if it doesn't have the correct amount, it can just make new ones and use them. And then if you switch between shaders, they can reuse them. Because then, otherwise, if you have many shaders, you get lots of buffers, but you don't really need them, do you? Because you break the draw call anyways when you change shader, so you can reuse the buffer for some other purpose at that point. Those are some things to think about. I think I need to... I won't have time tonight. It's 11 o'clock. We're going to end this now. So this is in a sort of a bit of a broken state. If I remove the alpha, do that, then it's working again. So my basic, you know, stuff is still working. But yeah, currently the moment you add this thing right now, that might work still. Yeah, this still works, but the moment I add that one and try to use it down here, then it has created one buffer, C buffer, for the vertical and the pixel shader, and it's setting the alpha in only the first one, but they should actually be shared, because or should they? Is it maybe this number? Like, what happens if you have... Can you reuse the register number between... If the pixel shader is using 1 and the VS is using 1 and the U both are 0, but it's only used by 1 at a time, can it then be reused? Many interesting questions. These are the kind of things I have to experiment a bit with. I think you can learn a lot about rendering programming by, like, thinking about things like that and then trying and see what happens, and like maybe look a bit in render doc, like, oh, this is how it works. You know, you can get kind of proof how it works. Of course, you can read documentation also, but sometimes you just need a little test. Anyways, that's it. All these things still work. Yeah, good. Gonna fix the font. The font rendering here is a bit problematic because it's... I might have to port the font stash stuff, because I'm not sure how it... Because it's a bit blurry, as you see, and it's because this uses a zoomed up camera, but then I need to feed that zoom into the font stash thingy, but then the spacing between them gets too big, and to me it feels like two different things. Like, you want to scale up the thing but draw it into an area that is not scaled, so you're just having, like, you know, it's sort of like a retina, like the retina display that Apple talks about. You know, you have like you have more pixels, but you're still rendering on the same size area, kind of. I know. I need to figure that out, because this currently, when I zoomed up this UI using a 4x camera, and then the font has just fallen apart. I have my little box 2D thing here. This looks exactly like it does. This is identical to how it behaves in with Raylib. This is an interesting. Box 2D is Y. Box 2D is Y up, and Raylib and Carl 2D is Y down, because with rendering, like 2D rendering, you sort of tend to think of the origin as up here, and then, you know, you think of a window as like, oh, it starts at up here, and then you, like a rectangle is like 0, 0, and then it's a width and a height. some people like having the 0, 0 in the bottom left, which is sort of more like a maths thing, right? It's sort of like you start here and then there's the width and then the height. And that's what Box 2D does. So is that a little bug there? Box 2D starts down here. So when you use Box 2D combined with Raylib or Carl 2D, then you need to flip. And that flip is quite annoying to kind of impacts how you can write a lot of your... Wow, this one is going crazy now. Why? Is it getting more and more powerful the longer I have the program running? So I did think a bit for a while, like, oh, maybe I can have configurable Y up. I was thinking like that. Maybe I can make it so you can choose. Is it Y up or Y down? Or negative or positive Y up. But having that configurable just utterly breaks your code, because you do so many, like, just look at this stuff. Like, here is draw rectangle. Okay, if I flip the y-axis, then actually I think I need to flip the screen. I was thinking maybe I could just reverse the screen and then reverse all the texture coordinates. I don't know if that... You just flip the screen upside down and you flip the texture coordinates, but I don't know if that works. I'm not sure. But yeah, here you would have to, like, move this to here and stuff, like, because things need to be the other way around. Anyways, we'll see. Just gonna remove those prints and then we'll call it a day. Log.info. Right. So I'm leaving everything in a half broken state. It's still possible to use the library with the default shader right now. No problem. But if you try to do anything else, then it will explode. Here's the Raylib camera with tiny text. This is one of Raylib demos that I ported. For camera, they can rotate. Anyways, that's it for today. Thanks for watching. I'll see you next time. Bye bye.